Hey, Mike, we're back with season 7 of Haven's podcast, Measure Twice, Cut Once.
Hey, Jennifer Lee, it is great to be back here, not only for season 7, Haven's 50th anniversary, but can you believe this? Episode number 59. We've been doing it so long that we're at episode 59 of this podcast. What a crazy journey it's been on, and an exciting season to look ahead to as well. We're going to be talking building and renovating high-performance homes, energy choices, design and building solutions, and of course the components that make up these amazing homes that we're building today.
I just really can't believe that we're on episode 59 already. It feels like we just started this a few weeks ago. We've got a great lineup of industry experts to walk us through the latest in building science and the choices available to build and design the home right for you.
Well, I'm really excited about this episode. Our guest, Anton, phenomenal human being. We've worked together on some committees for the Homebuilders Association. We've known each other quite a long time. Although when I met you, you were working for a window manufacturer. You're doing something a little different now. Please, welcome to our show. And please tell us a little about yourself and what you're doing these days.
So for those that haven't met me, I generally like to introduce myself as Anton VanDyk. If you've never asked me, I'm 6'8".
You're tall. You're taller than Mike, which if you've met Mike before is an anomaly.
Yeah. So I say it because then I don't have to be asked anymore, right? So I did play basketball at one time in my life, more volleyball, and the weather up here is just beautiful. So
isn't it?
Yeah. So that's a little bit about who I am. I recently left window manufacturing and window installation. Over the years of my career, I've always focused on building science, the envelope. And even before that, what was interesting about graduated from BCIT in the late 90s, right when leaky condos was all over the news.
Leaky condos.
I remember those.
Which was a very interesting time. And to see where we've evolved today as a construction industry, seeing what happened with leaky condos and then where we're going in energy and the envelope and the building science, it's really become a very technical, very proficient, very interesting industry. And so I always like to say I cut my teeth. I was the 22-year-old kid on a ladder crawling up buildings with a drill and a moisture probe trying to find where the buildings were leaking. And so I probably spent a decade just investigating buildings, why they weren't working, what failed, why did it fail? And then sort of the natural segue was to get into windows because that's just such a major component of the building envelope. And over time, started seeing how architects were specifying windows, how builders were selecting windows, how they're being used, and how energy codes were being written, how energy designers were specifying windows and going, wait a second, there's some opportunity here for some really cool technologies that go into it. And so what I've learned over that 20, 25 years, I decided to kind of hang up my manufacturing time, installation time, and focus on consulting. Everybody likes to say there's lots of consultants out there, but things are difficult to navigate. So my goal now is to try to help people, homeowners, builders, designers, architects, anybody involved in construction to pick the right window for the right use, for your right comfort, the right environment that you want to be in. So sort of using that experience to basically come to where we are today and seeing what we can do to improve and make homes more comfortable.
And you had an experience when you were younger with not so great windows. Can you tell us a little bit about that? How inspired you today?
Yeah, so personally, I went down this path of discovery for myself about why am I passionate about this topic? What's driving me as a human being to want to help people with this? And I came to realize when I was between like 8 and 12, the house I lived in was built in sort of the early 80s. I had a second floor bedroom with a west-facing window, double pane, no low E on the glass, kind of your run-of-the-mill 1980s style window, the type of window that everybody's replacing in homes today. And it was so hot in my bedroom in July and August that I literally grew up living in a tent in the backyard of my house. Now, I loved camping and I loved tenting, so it was a win-win. But that was kind of how I started to understand once I understood how much heat from the sun will come through a window that's facing west as the sun is setting in July and August. When I started looking at the science and the math and the numbers behind that, that's when I went, aha, that's why I didn't like my bedroom growing up. And so now I can actually look at it going, we can actually use data to prevent that from happening in homes today. And so that's something that I really want to bring to the table, to the industry, that be aware that you could create the same consequence from the 1980s when you bring in high heat gain concepts into windows, like some energy codes allow. That's where I think I want to be sort of important on there, and that we can actually do good designs where we can prevent that. So
Actually, it's so interesting that you mention that because it's something we don't think about a lot, especially in older buildings. Like I know with my family's construction company, we've gone in to renovate and we take away area rugs and stuff and look at hardwood floors. You can really see the discoloring from the sunshine coming through too. And it's like, oh, if that's getting in and discoloring your floor, what else is it doing to you in your home? Like,
Yeah, there's like, don't like to always get too technical into it, and you can kind of start to break things apart when it comes to windows, but glass is glass, right? And so, if you look at what comes, we look through glass just as much as things come through glass, light comes through glass. And what comes from the sun is infrared, ultraviolet, heat, which is infrared. Like there's all these different mechanisms. And there's technologies now where you can put coatings on glass that prevent that UV degradation of interior finishes. And that if that's the goal in mind to prevent that from happening, there's an unintended consequence that comes with that selection of material. And that's what I'm hoping to have conversations about with people is that if your goal, for example, is to reduce UV degradation of interior finishes, it may compromise the visual light transmittance and how light the house is. That's a consequence. Are you prepared for that? What are you doing to mitigate that? How are you dealing with it? It might, so there's different ways of sort of dealing with those types of design metrics and just not, what I actually like to break apart is this concept of silo design, right? So you might say the silo design is we want a window that reduces fading of our flooring. But what about the heating system that's going to impact? That's an integrated design concept that starts to come into that type of selection process.
So I got a question for you. You just said glass is glass, but windows aren't windows. Different windows for different thermal gains, different windows for noise. Can you talk a little bit more about that? Because for people who don't understand windows and the technology behind it, it can seem, like it's pretty simple, or it can seem almost mundane. And the one thing I love about you is you make it not mundane. You make it very exciting and dynamic. Talk about maybe a little about some of the different types of windows, though, if you could break it out for us, just so we understand. Because I think that'll make the rest of this discussion a lot more clear and easy to understand as we bring things into context.
Yeah, it's a good way to back up here a fair bit. And if I take my experience in renovating homes, renovating windows, and talking to homeowners that, you're sitting at the kitchen table and you're talking about the existing windows in their house and what you could upgrade the windows to, I think this is kind of part of that conversation. So most, if you look at a window, would think a window is glass and the frame. Some people think a window is just the glass. The number of phone calls I used to get going, we want new windows, but actually what they wanted was new glass. So the frame that the window is sitting in, that's called a frame. Then you got the glass. The part of the window that operates and moves, the terminology we use is a sash. You could just say operable part of a window. Those are the three main components of a window. So if you go back to 70s, a window back then was a single pane of glass, nothing on it, just clear glass, in an aluminum frame that was what we call non-thermally broken. They make electrical wiring out of aluminum. That's how conductive it is of energy. So not the best building material to be non-thermally broken. Fast forward into the 80s, you start getting thermally broken aluminum frame windows, and that's a little piece of plastic. There'll be a chunk of aluminum, a piece of plastic, and a chunk of aluminum. That thermal break, that's like a resistor to an electrical circuit type of thing. So it's reducing the amount of conductivity that comes through the frame. And then you would go from single pane to a double pane window. And this is what people are used to when the window fogs up. It gets all hazy, you get moisture in there. So that technology was, it's old technology. The seals weren't that great. The gas in between the glass would have just been air. Did it have what we call a desiccant? When you buy a suitcase or a purse, you get a little white pouch, that little thing in there you throw in the garbage.
That thing.
Do not eat it.
That's what it says, don't eat it.
that is what we call as a desiccant. So that basically is absorbing moisture in that, so you don't get mold in it when it's going in transit and being shipped around the world in a container, that type of thing. That same material in modern windows now in a double pane window will exist in the perimeter of the glass, which will absorb that moisture to a certain extent. So as you fast forward, you get into the 90s where you go from some aluminum to vinyl. What we call PVC, polyvinyl chloride. That's the plastic windows. Became very, very popular in the late 90s, early 2000s when energy codes started becoming more strict. BC came out with what's called the BC Energy Efficiency Act, which regulated the thermal performance of windows. It pushed manufacturers to innovate and upgrade to go from non-thermally broken to thermally broken aluminum to vinyl as the way the industry progressed. And at that time, you're still dealing with double pane glass. Then the next upgrade would have been probably from a vinyl window to triple pane. And that was really the maximum performance you're going to get out of a window. Today, however, we have this technology called low E coatings, low emissivity coatings is what it is. And this is microscopic elements of silver and zinc that are applied to the glass as a coating. You can't see it, it's invisible. Sometimes if you look at a window, you'll see this green hue. That's generally an indication of a coating on the glass. That type of technology is really what we're talking about today in regards to what we can put on the glass surface now to help, in a roundabout way. Filter is kind of a very non-scientific term, but filter how energy flows through a window, from reflection to refraction to filtering to reducing. And so we tend to not necessarily think of a window, a high performance window, as triple glazed alone. We look at it as what type of technology is actually in the system of a window. And then the frame technology's evolved a lot as well over the last probably 20 years in regards to multi-chambered windows. When people talk about passive house products, passive house windows, if you take a cross-section of that type of frame window and compare it to a non-passive house window, you'll notice a significant difference in the number of chambers inside a frame. All the chambers, what they do is they decouple the interior from the exterior. And so the more chambers, the more honeycombing kind of effect you get, the more insulating value you get out of a window type of thing. And so an overall window rating, it's just not the glass. It's the glass and the frame and the coatings and all the technology that goes into it. So there's a massive evolution of windows from probably 1970s to today. And, sometimes I find the understanding of a window is about a decade behind what actual technology is available today. Think of it as computer technology. I'm not a computer tech person. I still think of stuff from a decade ago because I'm just not part of that culture. Whereas in Windows, I'm in a different sort of setting. So,
wow. I never thought so much about windows, and I come from a construction family because you're just like, oh, they're important to the house, but you don't realize that there's so much science behind them. And for someone that's like looking for windows, I would just assume that triple pane is the best, but apparently not necessarily.
No. And I have to be careful with how I talk about this because I've used this concept to kind of bring awareness to the technology. And a good example is I developed a window that performed better as a double glazed window than a triple glazed window, which might seem impossible to do because you think more glass is just going to be better. But this is where technology can come in, and with a good frame design, with lots of chambers, lots of material in it, something that's decoupling or a good thermal break. It's not conducting energy through the system. With a double pane window with advanced low E coatings, you can actually get a higher rated window thermally, its overall rating, better than a triple glazed window. Now, you can do really good triple glazed windows. So what I like to say is there's bad triple glazed windows and really good triple glazed windows, just like there's bad double glazed windows and really good double glazed windows. So the real question comes down to is what are you looking for overall performance? And that's where the energy advisors start to come in, where they start specifying the actual thermal performance output. And I like to go back to an example I had when I was bidding on a project for windows when I was in the window manufacturing, and there was a specification written by an architect, and they specified that all the windows had to be triple glazed. And then they also specified the thermal performance value of the window, which I could meet with a double glazed window. And so I actually proposed to the contractor who we were bidding to that we could provide them with a lower cost solution, double glazed windows. They're lighter weight. You can get bigger sizes. You have less stress on the hardware, all these things that come with an advantage of a double glazed window. And their comment was, well, we've marketed the building as high performance and being triple glazed. And I said, but I can get that same performance out of a double glazed window, which if you start factoring in embodied carbon and embodied energy and all of those things, the question about why triple started to kind of rise to the table. And so it was a matter of building awareness that if you're going to use triple glazed windows, do it right. Use the proper triple and integrate it well within the design of the whole building.
Well, it's interesting you say that because when we're talking about building energy efficient homes, you're right. The mentality is let's go with triple glazed windows. But the fact is if you're working with the right energy advisor, the right carbon consultants, they can help you figure out how to go to double pane and take that budget that for the triple pane and put in other parts of your wall assembly to further increase the efficiency of the home. So the value of talking to someone like you is incredibly high. I do want to talk a little bit of the carbon, like the low carbon versus high carbon, embodied carbon. How does the manufacturing of the windows themselves contribute to the modeling and the mapping of the house?
Yeah, the carbon conversation is an interesting one. I used to talk a lot about embodied energy, just the amount of energy that goes into making a product, not so much about the carbon side. And now the carbon conversation has really taken that over. And if you've ever seen how glass was made, if you ever go to what we call a float plant, you literally are melting sand. So you think about how much natural gas is burned, melting sand. You're not using hydroelectricity. I don't think anybody is, to melt sand.
Nothing solar yet?
And then it turns into this toffee-like material, so it's all sort of stretchy and gooey. And then it's stretched out onto a molten bed of tin. Like it's literally about half the size of a football field of molten tin where this glass floats on, and they stretch it and they create this whole thing. That's how glass is made. So glass in and of itself is a very, very high carbon consuming building material. There's no way really around it. It's just reality. You can't say, let's do it with less carbon unless there's some major innovation that's going to come up with on how to melt sand into glass. And so when you're looking at selecting just triple glazed windows as your design parameter, and you're not focusing on what the actual energy rating of the product is, you might actually be putting in more carbon-based materials into your building than you think. And so the conversation that's starting to occur today in the industry, which is a really good conversation that people are having, is what is the operational carbon consumption, meaning the heating and all of that, versus the carbon consumed in the production of the material. So let's take a mild climate like Vancouver, right? It's winter at 7 degrees today. How effective is a triple glazed window? And I'm going to say a poor triple. So let's say take a triple glazed window with no coatings on it because somebody had a budget in mind. They wanted a lower cost triple, but they want triple. That's their number one thing. So you put no low E coatings on this glass, so it's cheaper. In a mild climate like today, could we be consuming more embodied carbon to make that product than the building energy consumption is not going to use over its life cycle? Those are these really big, important conversations that we need to be having in our industry. And I like there's examples of, today's construction energy modeling systems. And so for those that don't know, pretty much every project now, you need an energy modeler, energy advisor on a project. And they're going to do all these different calculations to determine what building materials have to perform. So the whole building creates this output of performance. And windows are a big component of this. When you think about it, a window comprises of 20 to 30% of your wall area. Right. So if you're just looking at it in a very simplistic way, it's like there's massive opportunity, 20 to 30% of the wall area. What can we do with that? And so an energy advisor will come up with a calculation and determine the required energy performance of the windows and doors on the project. And they'll specify what's called a U value. That's its thermal resistance value. There's a solar heat gain coefficient. This is how much heat from the sun can come in. Those are the two main metrics that are used for the energy advisors. And then there's other things like visual light transmittance that also come out of these calculations and so on and so forth. And the interesting part about the energy codes today is they can be traded off with each other. There's this what we call trade-off process in the building code. And so you can take one product that performs worse and you can put another product on that performs much better. And you can take advantage of the better product to compensate for the product that's worse. And so this is how sometimes if you're building an ultra custom home and I'm working with a client right now, he wants these like 20 foot by 8 foot multi-sliding aluminum and glass paneled sliding doors. Well, they don't meet the energy code requirements, but you can trade them off with other better products to allow that product to be used. So there's paths to be able to use it. And I was working with a project and a friend, and they were wanting to put triple glazed in their house. But the thermal performance value specified by the energy advisor was achievable with double glazing still. And so what we actually proposed was, instead of using the lower end triple glazed window, was to spend about $500 more to upgrade the triple glazed window. And by upgrade, I mean adding more coatings to the glass. So it cost about $500 more on all the windows for the house. So fairly low cost. and nobody was prepared to do this, but then I recommended that they go back to their energy advisor and remodel the house with the better windows and recalculate it based on that metric and higher performance. And what it resulted in was the reduction of about $3,000 in insulation in the wall area, which turned into a net savings of $2,500 on a project. And none of this would have happened unless we actually would have said, hey, we'll give you a quote for what was designed, but why don't we give you a quote for this other performance option as well? And here's what you do with it. Because I think that's the part that gets missed a lot in construction is, well, what do I do with that? And so there's sort of an idea here of sort of spinning around with this integrated design approach and working through, working with designers and product manufacturers and suppliers to find the best solution.
Well, when people are designing homes, especially here, I see a lot, if you have a view, a lot of people want to have so many windows to let that light in, see the view of it. Even with quality windows and the proper ones, would you still advise, and that's probably where the energy advisor comes in, but to do less windows, even though they're good quality, to make your home better efficient? Or can you still have a billion windows as long as they're really good quality?
Less windows is definitely a solution to a problem. I don't think it's a solution that people would buy. If you're building a house and doing a custom house and we said, hey, our solution is to put less windows in this house, I don't know if a homeowner would be overly optimistic about that idea, especially if you're on a southern slope like White Rock or North Vancouver, West Van, those types of regions where, your views are beautiful. And what do you typically see? Or let's even take Kelowna. Kelowna is probably a really good example of predominant southwest facing the lake, right? What does everybody have in these homes?
Lots of windows.
Lots of windows. And so this is probably one of my biggest pet peeves and why I like talking about this subject a lot when it comes to helping homeowners out solve problems. And, spending about 50% of my window experience renovating existing homes and the other half providing windows for new construction, you kind of see, why do people replace their windows? And then you look at what type of windows are people putting into new homes and why is it different? If you had an opportunity as a homeowner to sit down with a window, a window renovation industry, the window company is sitting across the kitchen table with the homeowner, guiding them on what type of windows to put in their house. In new construction, the window expert is behind their desk and doesn't necessarily have direct access to the homeowner. And if you start to understand why homeowners replace windows, in my experience, majority of window replacements that are done in our climate here in southern BC is because of overheating, not to reduce heating bills. And when you tell people that, they're like, oh. So when you look at a house on the slope in White Rock or North Vancouver that's got, 6 foot wide by 8 foot tall windows in this big vaulted area.
Which is gorgeous, though.
It's beautiful. But the blinds are closed.
True.
And on my way here this morning, I drove past a building on First Ave, First and Clark. When you head west down on Clark, there's a building. It's a 3 to 4 story building. About 50% of the windows are all facing south. And it's end of February, 7 degrees outside this morning. And guess what the windows are, what's drawn on every single window?
Blinds.
The blinds. So this is a building that I know generally incorporates high heat gain design concepts to reduce heating loads in the wintertime, because that's why you would put high heat gain glass in a building, because the energy calculation in the system that's used by energy advisors basically says, if you can get free heat from the sun, you reduce your heating demand, which is a good thing, because if you're burning natural gas to add heat into the building, you're going to reduce your heat load. But the blinds are closed. And here's the kicker. Half the windows were open. Oh. And it's the wintertime.
But it feels like you're breaking even at that point, because then you have to run your air conditioner. It's like 1-for-1 odds.
So this is where the conversation gets really interesting in regards to using air conditioning to overcome the concept of high heat gain. So the current energy modeling program that's used pretty much industry-wide for energy advisors, you input the window data, and there's a spot where you can put in, it's a number called a solar heat gain coefficient. And it's a unitless number. It's just a number. And it's a number that comes out of a certain window rating system. And because it has no unit to it, it's hard to understand if I told you a window has a solar heat gain coefficient of 0.48, What would you think that is?
I have no clue, but I'm not great at math either.
No,
so you're like, right now you're telling me I don't know, just pick my window
So
for
there's
me.
no unit to it. There's no measurement of what it is. It's a ratio number that's out there. And I said, could you tell me the difference between a 0.18 versus a 0.48? You know, what's the consequence that can happen if I pick that one versus another? And to the average person, they have no idea. So homeowners is trying to use this number to determine if my windows, if I build a house in White Rock or North Vancouver, am I going to have the blinds closed all summer? Well, if you have a 0.48 window, yes. If you have a 0.18 window, no. That's the difference right there. And so, but it's counterproductive because the energy software that's being used likes to factor in high heat gain as a free heating source. And so there's this sort of tug of war going on a little bit as to how do I do this? And a lot are using air conditioning or heat pumps that are going into almost every home now as the way of overcoming the high heat gain windows. Well, in a society like Vancouver, where air conditioning is not the predominant feature in a lot of existing homes, and now it's pretty much, I bet you every house you build has got air conditioning or heat pump in it today.
After our summers.
I think it's mandated now.
Well, so there's some mandates coming with minimum temperatures in rooms that can happen in houses. And the reality is you can't build a house today without putting a heat pump in, for the most part, in my opinion. And so that brings air conditioning in. In combination with high heat gain windows, now you might go from having no energy demand in the summertime to now energy demand in the summertime. So these are these kind of sort of tug of wars that we're sort of playing with on a regular basis. And there's a tech talk actually on the Fenestration Canada website if you ever want to dig into this issue and the consequences that can occur sometimes of this sort of situation. And it's when high heat gain is designed into a window, people will find their own solutions to reduce the heat gain. And that's can be a bit scary because now the design intent may not have been there. The supplier who supplied the windows may not have assumed you were going to do that. And in this tech talk, the homeowner added what was called heat reflective blinds to the inside. Okay. So think about this sort of concept is you have a window that allows in lots of heat, and then you put a heat reflective blind right on the inside with a plastic frame.
Oh.
And then July and August, what do people do in July and August typically? Where do they go?
They go away.
They go on vacation.
Yeah.
And what do you do when you go on vacation if you have air conditioning?
You turn off the air conditioning?
So the designer's intent was we'll use air conditioning to overcome the high heat gain. The homeowner's solution was to put heat reflective blinds and turn the air conditioning off and go away for the summer. Returns, comes home, opens the blinds, and the vinyl frame had
Melted?
heated up enough to the point where it softened the frame to distort the frame and melt the frame. So it takes about 160 to 180 degrees Fahrenheit to get it to that point. So that's sort of the idea
sounds
here.
dangerous.
Where I'm trying to go with this a bit is your design intent may not match how the homeowner actually uses the home. And so it's important that sometimes I've always said simplicity is best. You know, from a homeowner's perspective, the simpler we can make certain concepts, the better we can go with it. So,
well, you've just underlined one of the things we've talked about on all 7 seasons of the show is working with the right professionals. And you've just underlined 2 things. One, why we'd want to work with a consultant versus a salesperson directly because you have additional insight. And secondly, why you might want to bring an energy advisor into the conversation at the same time, because it feels counterproductive to have you do one set of modeling and having an energy advisor do a second set of modeling when if you collaborate, some of these things that are happening could be easily avoided, like don't use that particular type of blinds or shades. This has been just unbelievably enjoyable conversation, and as well as being very educational and making my head spin, I've also, got a lot of interesting conversation points out of it as well. Have really helped me understand a little bit more about what you do. Before we keep going, though, we do have to take a short break, thank our amazing suppliers, and then we're going to come back and keep this conversation going because I suspect we have a lot more ground to cover still. So give us a couple minutes. We'll be right back, and we'll talk to you again soon.
Measure Twice, Cut Once is grateful to our podcast partners, Fortis BC, BC Housing, and Trail Appliances. Support from our partners helps us share expert knowledge and resources with families looking to build, design, and renovate the home right for you. Trail Appliances makes everyday life better with the best selection in Western Canada, hassle-free delivery, and a price match guarantee. You'll always get the best deal. At Trail Appliances, you'll love buying an appliance as much as you'll love using it. Affordable, accessible, quality housing is a top-of-mind issue for many British Columbians. For BC Housing, creating access to housing solutions that meets everyone's needs is a guiding principle. BC Housing is working with governments, nonprofits, and residential construction industry members to create practical solutions to BC Housing's challenges. To learn more about BC Housing initiatives, programs, and services, go to bchousing.org. And we all need reliable and efficient equipment for better comfort, health, and safety of our homes. Whether you want to adopt some energy-saving habits or take on major energy efficiency upgrade, Fortis BC can help you save energy. Be sure to visit fortisbc.com, where you can also find amazing tips on low and no-cost ways to save energy. Plus, great information on what Fortis BC is doing on low carbon energy with solutions such as renewable and natural gas. Competition alert! Listen and like this episode for your chance to win a Napoleon Prestige P500 stainless steel natural gas barbecue valued at $1,600. Compliments of our podcast partner, Fortis BC. Details at havan.ca/measure twice, cut once. Now let's get back to our guests.
All right, welcome back. Now, this is an interesting part, and I think this is going to be something that's going to resonate with a lot of our viewers and listeners, is about what the builder and the homeowner can do together. And I'd like you to maybe talk about that from your perspective. How can we get greater collaboration, like we were just talking about? But in that case, that's more about the builder, the homeowner, and yourself. So do you want to talk about that a little bit?
Yeah, I remember when the step code was first being presented in our construction industry, and going back, I can't even remember what date that was, and the whole purpose of it and the intent of it. And at the same time, there was a lot of conversations going on around about this integrated design approach. And I actually had the privilege of working in Seattle from 2005 to about 2011. The company I worked for, I just went down there because they were having the same leaky condo issues, and just not to the extent that we had it here in Vancouver. And what I noticed in that construction industry, especially in the multifamily sectors, is they had these things called design charrettes on almost every building. And they would bring in every consultant, every designer, every core trade. Even though the trade hadn't been selected yet, they would hire a trade that was qualified to talk about their materials and building materials to come to this design charrette. There would sometimes be 20 people around, depending on the size of the project, around this boardroom table for like 8 hours one day. And everybody would just talk about their design intent and what would it do. And then there was some core trades. And if you did some big commercial projects, you'd have a curtain wall guy there, and everybody would hash out, what would work and what didn't work. And so it was really a very formal, what I called the formal kind of integrated design approach. And I think it might have been driven in the US market because it's very litigious. And so that was their way of kind of like dealing with that. And so when I started hearing about the integrated design approach here in British Columbia in relationship to the same time the step code was coming in, and there was fear that the step code was just going to drive up construction costs and it was going to make things just, construction's already expensive. What does this mean? I always say there's a fear cost. I don't know. I don't understand. Going back 20 years ago when I was like, we got to put rain screen on buildings, and people are like, that's just ludicrous. Well, no one's having that conversation today. No one would even think twice about not putting a rain screen on a system. In fact, if you didn't, you're going to have a tough time selling a building if you didn't. I saw buildings get fixed that they didn't even leak. They got fixed because it was non-rain screen stucco. And they knew from a marketing perspective that they had to have that. And so when I start to look at, what can homeowners and builders do? It's really embracing this concept of the integrated design approach. And I think we think of the integrated design approach as, let's just bring some designers together and hash out a design. The industry is moving at a rate so fast. Code is changing. I would say code is changing faster than the ability of R&D can occur. That's one thing that's happening right now. Now, there's a lot of R&D and development of product that's happened as well, but we're faced with some significant code changes from Vancouver's code to the BC codes coming out here in a week, almost a week and a half. the national codes, and there's the harmonization with national codes. So there's a lot of like, okay, what are the codes going to require us to do? That's one. Code proficiency is going to be an incredibly important skill set for people to have. I learned this, I got involved in a code committee actually when about 2013, 2014, and I actually started to learn, the people that write the code are humans. And they write the code with intent, and they have purpose behind the code. And if you actually learn what their intent is with the code language, you can actually develop systems around the code. And so I'm like, the number one thing I've always said to people, if you're in construction, get on a code committee somehow, some way. And then I started reading the entire code front to back every 2 years. And so I would spend about 40 hours every 2 years reading the building code. Don't ask me why I enjoyed doing it, but I figured out if I read the building code, because a lot of people didn't read the building code, I could just, knowledge is power, right? And being aware of the code and how to use the code to your advantage is one way to bring down construction costs. It seems kind of weird and that simple, but there's so many opportunities in the code to make things simple if you know how to use the code. And then the integrated design approach and how homeowners can work is, a lot of builders, especially for custom homes, they have their go-to trades. A lot of them like the same window supplier, the same door supplier, the same siding contractor. They get comfortable with their trades, or they might bounce between 2 or 3 different trades for what they do. So it's not like you can't bring a trade or a supplier to the table at the design stage. Some are, not necessarily wanting to do that because it might, does it change the competitive landscape of how, pricing is done where you get multiple bids. But by bringing a supplier or a trade to the table at some of the early design stages, you can actually now integrate technology that's available today that designers may not be aware of, because let's face it, they're designers, they need to know a little bit about a lot, right? Where a trade needs to know a lot about the little thing. And so if you can harness that relationship in an integrated design approach, you have the opportunity to develop something significant. The other recommendation I've always had is don't hire an energy advisor for a one and done assessment. Have them do an initial assessment so you can get the baseline of the building figured out. Then you go out to tender, you get all your prices, you get all your materials, you get with your trades. But ask each trade that has an effect, where their product that has an effect on the energy consumption of the building. Ask them if there is a better solution that we're not aware of. And if there is, ask them for those performance numbers, and then take all those performance numbers, give them back to the energy advisor, and have the energy advisor recalculate the calculation. So it's basically like double checking your math. And what you might find at that point is, this is where I get to the idea of triple glazing and the high performance, low performance, is a small cost upgrade could actually save you money somewhere else. Similar to if you want, if a designer is saying, well, we have to put smaller windows in order to meet the energy code. Well, if you actually put this type of glass in, you can have bigger windows. But if you don't know that at the design stage, you're going to miss that opportunity, and you might draw smaller windows thinking that's the only option available to you. So it's really, it's become so technical to a certain extent that, engaging with trades and suppliers that have the capability of providing options, it's in a roundabout way one of my reasons for going out of manufacturing and into consulting, because I saw a need for a neutral voice to be out in the industry that could represent this in a generality, and I'll look at everything from a 20-story high-rise to 10 stories to 6 stories to a single-family home. It's all the same. These same design parameters, are the same across the board.
And I would assume too, because it gets so technical, why it's so important to have an energy advisor too is to also showcase like what would make your home comfortable. Because I think the thing is, it's great to have all this tech and we know it's more energy efficient, but like, what are the benefits as you as a homeowner being there? Are you going to be comfortable? Are you going to be just the right temperature?
From a homeowner's perspective, I could tell anybody who's involved in any aspect of energy, the homeowner cares about comfort above anything else. We might think it's about reducing energy bills, that type of thing. But predominantly, if you can make a house comfortable, you will win over a homeowner. Number one goal. Now, a comfortable house tends to be an energy efficient house. That's another thing that people don't always realize. So if you sometimes if you focus on comfort,
That makes more sense too. It's not super technical.
yeah. And when I say comfort, right, when I look at it going, a design parameter, for example, that we were seeing pop up a lot was we want to reduce our electricity consumption. So we want less energy used for lighting. So we're going to specify what we call a high visual light transmittance rating for a window, which means lots of sunlight coming in and making it nice and bright, just like the room that we're in. Well, the unintended consequence of high visual light is high solar heat gain. How does a tenant, rental, homeowner deal with high heat gain after the fact? They close the blinds. So what good is a high visual light transmittance if the homeowners close the blinds? So this is a really good example of a siloed design parameter that appears on paper to be really, really good because it's going to reduce the electrical load that's going to be consumed. But in fact, it actually increases the electrical load because blinds get closed and people leave the lights on all day. And so we have to actually step back. And when I tell people about high solar heat gain, just like when you buy a car, you see that car everywhere. I can assure you now, when you drive around and you leave here, you're going to drive around and look at all the south elevations of buildings with the blinds closed. And you're going to go, those units are all overheating. And or the windows are open and that type of thing. And so you can start to see human behavior and how how we choose to live in a house and human behavior versus, what we can design. And really the point I'm trying to get across here is there are some really cool technological design features you can put into a window that avoids all of this. And if you're aware of it, you can put it in.
Well, it's actually funny because as you're mentioning blinds, I'm looking at the building right across the studio and the majority of them have their blinds closed, and that's all I could think about.
Yeah.
So I feel like taking some of your cards over there afterwards.
Yeah, there you go.
Okay. So you talked a little about choosing windows. And it feels like there's two parts to that, though. There's the aesthetics, getting windows that look the right way for the project, and windows that perform the right way for the project. How do you balance that out? Is there metrics that you use, or is it just many, many years of experience knowing if we do this, that will happen?
Yeah, I think that's it. If we kind of learn through, I would say we've all learned our lessons through what hasn't worked, bottom line. And if we're not, we're failing society. You don't know what you don't know. Did we know we were going to create leaky condos when we were building in the 80s? Did anybody predict that when they built a building with stucco in the 80s that it was going to fail within 2 to 5 years? Right? So everybody goes into this with good intention. Everybody goes into it. And what's important with it is, what is the unintended consequence? Now, the challenge is if you've never experienced a consequence, you don't actually know. So the experience of an energy advisor, the experience of designers, the experience of your entire team now plays a significant role in what you do. Now, what smart designers will do, and what came out of the leaky condos was architects went, we're not building science experts. Therefore, this entire industry of building envelope consultants was created. Didn't exist before in our industry. We don't even question not using them on projects anymore. And so when you actually look at, and what I always recommend is let an architect draw a window for the aesthetic look of what they want, and really, send that. I see builders will send that design to their window supplier, their preferred window supplier, and say, what do you think? Tell me not what I want to hear. Tell me what I need to hear. So I'll use an example of a design that was done for a project in Kelowna, southwest facing windows, 8 feet by 8 feet, really big. And, I voiced some concern. And the comment was, well, someone else will do it. Well, okay, what good is that? So, my concern means something. And I'll go back to that window, that project where that window melted I talked about. It was a townhouse complex I was involved with. And the project was going to go from step 3 of the step code to step 4, right? So just a much higher rating. There was going to be some funding available to do it. Here's the problem: was the design was done. The size of the windows, the configurations were done. There was no appetite to go back to the drawing board to redraw the exterior envelope of this, building. And the energy advisor figured out that if they changed the solar heat gain coefficient from about a 0.25 to a 0.48, which is a high rating, in my opinion, if you don't understand what that means, and the entire building went from a step 3 to a step 4. So now just by adding high heat gain, the project was deemed to be more energy efficient than the other glass option that went into it. And that coating going on the glass is the same type of coating that caused that window to melt. And so that's sort of the idea of, are you prepared? Like, so are you aware of how your performance specification is going to impact the overall building? And so an alternate solution on there would have been, if you made the windows 6 inches smaller on both sides and increased the wall to window ratio, you could have gotten there. And so there's different ways to actually do it. And so when it comes down to sometimes some early architectural design, some buildings with really big windows can actually be harder to design when you're using some technology that goes into it. So,
is there a way to reduce brightness? Because like my parents are in a fairly new building in North Van. They're high up and they have a gorgeous view. And what I love about it, because they are south facing, is the sun. But we always close the blinds because the sun is blinding. Yeah. Like if you're not, like it hits like the casing, the metal casings on the wall, and it's just like we got to have sunglasses on in the apartment building.
So in that case, my first one is, you can't really say anything until you know what type of glass coatings you have on the windows, right? So how old is the house?
It's about 10 years. It's apartment building.
Yeah. So, it's kind of predates some step code stuff. So there was probably very little effort put into solar heat gain discussions because it was just not talked about at that time. So it was all about winter performance at the end of the day. And there wasn't energy calculations going on. So they probably got just your code minimum basic window, which can be somewhat okay for performance. But, you get some big south facing ones and you're going to feel it at those peak demand kind of periods. There's a very simple glass upgrade that could be done. It'll make the glass slightly darker. I put it in my house just so I could feel what it would feel like from the darkness. And it's what we call a triple coat low E instead of a double coat low E. So it's 3 layers of silver as opposed to 2 layers or 1 layer of silver, which will make it a little bit darker. And it will reduce the UV coming in, and it will reduce the solar heat gain infrared that comes in as well. So there's some very basic options to sort of tweak it and change it if you wanted to look at that type of thing. And that's where, a window expert can come in.
But you can't do that, though, if you're in a condo.
Well, you have to work with your strata in order to figure it out. So the other part is like shading options type of thing. So, this is where I get a little bit of flack. Solar heat gain, high solar heat gain can be a good thing. It's used in a lot of passive solar designed buildings. Some technologies that go back to the 70s. And it's the idea is the sun is high in the sky in the summertime, so big overhangs will shade the window so the sun doesn't touch the glass, which if the sun doesn't touch the glass, it doesn't heat up, you don't get the heat gain. But in the wintertime, the sun is low, you get that energy coming in because now the overhang doesn't shade the glass. And so, working with potential shading features, you get a lot of questions about, can I put an aftermarket film on the window? Very, very common question as a low-cost solution. Most window companies will not warranty the product once that's done because if you can put the wrong coating on the wrong surface, it can actually cause a significant heat gain system and can trap heat in and cause other problems. So it's generally not recommended within the window industry unless you have potentially just clear glass, like old 1970s, 1980s glass. That's usually where you see those sort of aftermarket films applied. But if you actually drive around to older homes back in the day, you'll see all these like canopies and overhangs over the windows.
Yeah.
Ever notice that?
I thought that was just a design aesthetic, but I guess there was a purpose to it.
Because there was no shading technology. There was no technology to reduce heat gain. So people would actually put retractable like awning shades that they could lift and move. You'll see some people put bamboo shades on actually, if you go to Europe does this really well, especially in their commercial sector. They'll put these big louver vents, blinds on the outside. Because what you actually want to do is once the sun touches the glass, it heats the glass up, which then heats the inside up. You actually want to reflect the heat before it actually touches the glass. So Europe's figured a lot of this technology out. It's not cheap, but this is where, external shading versus technology and coatings. It's the technology and coatings is really where the future of windows is going. So,
well, it feels like a successful project is a combination of a lot of different things, working with a lot of different professionals. And if that's one thing I've taken away from our conversation today, well, that's what we take away from all our conversation is hire the right team of professionals. And that's a huge part of that is why we would want to work with consultant like yourself, with an energy advisor, how you'd want to work together, how you'd want to work with an integrated design process. And at the same time, the huge difference choosing the right technology for windows can make, because one size doesn't fit all for clothing, and it doesn't fit all for windows as well. So I think, and it's really hard to make this technical a conversation easy, but you've done a very good job, because I could pay attention and follow along as well. So good work as well.
You mentioned one size fits all, and I think this is an important one, is the way windows are rated for North America, using the rating system programs that we have and the simulation software that's done, and something like Energy Star for Windows as well. These programs are designed to rate a window so that when you're shopping for a window, you can compare one manufacturer to the other. They're not actually, the numbers that come out of these programs are not actually numbers that you should be using for design metrics. So the actual issue that we're running into is the purpose of these values was not really intended for what they're being used as. And that's why it's important to not just take the number for what it is. It's to understand what the number means and where to put it. So a window on the north side of a house versus the south side of a house, if you're putting the same glass in, because the north side sees no sun and the south side does. Energy Star, for example, will rate a window with high solar heat gain as a good thing, boosting its value up, making it appear like it's a high rated product because it provides free heat in the wintertime. But if it's overheating the house in the summertime, what good is it? And why would you put the same window on every elevation of a house? The same glass coating technology. So real smart designs, if you want to spot a smart design, you'll see a design metric for the north side and the south side is being different.
Wow. Never even thought of that.
Are we, I'm just thinking of like replacing windows. A lot of people are thinking about that, but are there any type of rebates for window replacements?
So the rebate industry is definitely an interesting one. I think if I were to comment on it, I'd have to specify the date, but the federal program is, I think, winding down. There's a provincial program. And I actually want to give, the provincial program for window rebates is actually, I got heavily involved in how these programs were created and developed in regards to what can we do as an industry to provide good product to meet these rebates. And if you actually look at the difference between the BC program, the Better Homes rebate for windows, and the Greener Homes rebate for windows, which is the federal program, you'll notice the BC program does not link window performance to the Energy Star rating. It doesn't exist in the BC program. And that's on purpose, because Energy Star uses this thing called an ER rating. It stands for energy rating. It's a unitless number that combines solar heat gain, the thermal conductivity, and the air leakage rating of a window to give it a unitless number that a consumer, someone buying a window, could walk into a store and go, that window is rated 36, this window is rated 17, the 36 window is better. Well, is it? And so it's a very simplified way of doing it. And Energy Star rated windows don't care if it's on the north side or the south side. But when you use solar heat gain as a way of calculating this energy rating number, well, I always ask designers this fundamental question. What's a good solar heat gain rating of a window? And it's a total trick question. It's a trap. Anybody who answers the question, I can tell right away, doesn't understand windows enough, because the answer is it depends. Well, what's elevation, north or south? Is it shaded? Is there big overhangs? It's not about the window rating anymore. It's about the house orientation and everything that goes into it. And so the rebate programs, the challenge with some of the rebate programs is they like to simplify the rating systems. And so when I educate people on an Energy Star window, and I say an Energy Star window that meets 35, has an ER rating of 35, that uses a solar heat gain coefficient of 0.48, I can start throwing all these numbers out, versus a low solar heat gain window that has an ER rating of 17. Which window would you put in your house? The Energy Star rated one or the low solar heat gain one?
I would get a window consultant who would help me solve this problem.
But usually when I break it down and I show people how these are calculated and done, and I show an architect going, which one would you want to put in your house? They all pick the low solar heat gain window, especially in our southern BC climate, which tends to have a fairly long, from like May to September. You probably got your air conditioning on, right? So it's this idea of, and so the BC rebates actually recognize this in the early development of them. And that's why you don't see Energy Star rated product in the BC rebates. And it's only focuses on the thermal conductivity value in the BC rebates, which is a really, really good thing, It's doing a really good thing where it's not allowing you to put high solar heat gain. And so from a BC Hydro perspective, where they're using electricity to power heat pumps and air conditioners, they're reducing that summer load because you can't just put high heat gain windows in. And that's the message I'm trying to get across a bit on the new construction side, where energy advisors might use high heat gain as a design solution to overcome. So they're increasing air conditioning use as a result of that type of design metric. So, the rebates will evolve as time goes on. The message and the important part that homeowners will need to understand about rebates for renovation is you don't get a rebate for replacing your windows. And you don't get a rebate for replacing with code minimum windows. You get a rebate for replacing windows that are better than code. And so they use that platform, the renovation platform, to boost the demand for higher performance windows that exceed code, to demonstrate that there's a market for high performance windows, which then eventually become the code minimum down the road. So there's a real dual purpose when it comes to the rebate programs out there and how they're used in the system.
I'm learning so much. My head's spinning, but I'm learning a ton. And what's really poignant is we are still talking about doing a project. So you and I will be going for a coffee very, very soon to talk about this, because you just put a bunch of stuff in the conversation I never even thought to ask, to think about as well. So want to thank you very much. It's been a really, really great conversation. Oh boy, did we ever cover a lot of ground. But as always, it's been a pleasure. Thank you very much.
You're welcome.
And if I ever go to buy windows, you're coming with me, because I feel confused, but you give me a lot of good information. I don't want to pick the wrong ones. That being said, can you give one more tip for the consumer if maybe they're feeling a little daunted by windows?
The number one takeaway I would give, if overheating is a concern and comfort of your home that you're getting built or renovated or whatever, is ask the question, if the energy design for the home, does it incorporate high heat gain or low heat gain window solutions? That would be my number one question a homeowner should ask a contractor. And if the contractor doesn't know how to answer the question, pick up the phone, call your window supplier. They will know how to answer that question. And if you're not getting clarity, ask for 2 quotes, a low heat gain option and a high heat gain option. And then ask for the numbers, and then give that number back to the energy advisor, and then let them do it. So, or sit at the table together. That would be the other option. But just basically low heat gain, high heat gain, ask the question.
That's perfect. Well, before we go, just a friendly reminder to our viewers and our listeners, if you've just replaced your windows with these high-performance windows we talked about, and you'd like to look out your new windows at a beautiful new barbecue in your backyard, you can like this episode, listen to this episode, for a chance to win a Napoleon Prestige P500 stainless steel natural gas barbecue, valued at almost $1,500 from our fantastic podcast partners, Fortis BC. Details are available at havan.ca/measure twice, cut once.
And for notes and links to everything mentioned on today's episode, including resources shared by Anton, go to havan.ca/measure twice, cut once. Thank you to Trail Appliances, Fortis BC, BC Housing, Ramey Films, JPod Creations, and AI Technology and Design. It takes a team to build a home, and so does it to build a podcast. Thank you for joining us. See you next week.